we all want to have an impact on the world, and we want something to be left when we get to the end of our life, and we want to have had an impact on what's happening. And as humans, we're always asking ourselves, okay, what am I doing next, right? What's the next step for me? What's the great thing that I can do with my life? What would have an impact, right? What's going to make a difference? And yeah, that's a pretty high level talk, but that's what I'm trying to discuss today. As technologists, we're pretty lucky, right? We get to kind of decide what we want to build and create new things, and we're in the right spot to really have that liberty to have an impact, right? Make things different. So we're going to try to build a roadmap, which is what I promised in the title. And to build a roadmap, you have to understand the world around you, okay? And how that world evolves, and we're going to try to do that at the macro level, and then bring it down to where we want to be. We'll look at the major trends that are affecting humans and technology. Right? We'll look at the major trends that are affecting humans and their relationship to information. And then we'll look at the good and bad of information technologies. And maybe that'll give us a bit of a hint in terms of where we need to go and what we need to build. So first, human and technology. I can't talk about human and technology without talking a tiny bit about the internet. Okay, there's 4.2 billion humans on the internet right now. Okay, that's 55% of the world population. That's pretty amazing. If you look at the top here, North America, yeah, my parents, which are over 75, are on the internet. My kids, which are under 10 years old, are also on the internet. But when you look down at Africa and Asia, those numbers are much, much lower, right? And they're lower for a specific reason. Most of the population in those countries, and a lot of those countries, is actually under 15 years old, right? They're minors. They don't have the economic wealth and the ability to connect to the internet. But that's going to change in the next 10 to 15 years, right? So if we abstract the young people, we have the ability today to reach the world population, right? So that allows us to really have an impact. If you're going to build something today in the world, this is probably a unique time and a first in the world, in the history of the world, where you can reach every human being and have an impact on every human being on the planet. Okay, so how do they access the internet? Right, well, if you look at the shipment of mobile smartphones, right, and mobile phones, you see that there's actually saturation happening. Right? This was year-over-year growth from 2009 to today in the red curve. Right? And you see that curve actually going down. Or if you see the amount of shipments actually plateauing at the top, which means we've actually gotten to a point where the actual cell phone market is saturated. Most of the people today actually have a mobile device and a smart device, and that's how they access the internet. Right? So how many in the room here have friends who do not have a mobile phone? Okay, how many know someone who doesn't have a smartphone? Okay, well, I know someone. My son's teacher, he's in a special class. My son's teacher is actually does not have a mobile phone or a smartphone. So I asked her why. Why do you not have, she's part of that, whatever, maybe 5%? No, she's actually connected to the internet a lot. She's just always either at home or at school, and there's always either a phone or a computer right next to her. Right? So there's no worries that those exceptional people that we don't know are actually also connected on the internet. Okay. So that's for the internet, very high level. Now let's dig into computer and storage trends. And I think there's a few good insights that we can find here. First of all, Moore's Law. Okay, we've all heard it 100 times, and we know what it is. Before I started in this software business more than 10 years ago, I was actually in the DSP business, and we built high-end DSP cores. And the purpose there was to actually get to design the highest performance DSPs. And we used technologies that allowed us to have asynchronous cores. They weren't timed or anything like that. We followed Moore's law and a lot of things around that. But one of the key things that I noticed is a lot of people will extrapolate Moore's law and think it applies to a whole bunch of things, which it doesn't, right? And that's, I think, is more relevant here. The law says transistor density will double every 18 months. Right now, it's a self-fulfilling prophecy. It's not a law of physics. You understand that? But a lot of people will think, well, that means the cost will be cut in half every 18 months. That's wrong. And the other thing is people will say, well, the CPU speed is going to double every 18 months. That's wrong. And that we've seen a lot over the last 10 years. So if we really want to understand the impact, we need to understand the actual law itself. So if you design in the latest technology nodes today, right, it's actually going to cost you a lot more than if you're in the lagging technology. Right? And the reason for that is very simple. The equipment, yeah, there's the fact that the yields are lower, but the equipment to build those chips is actually getting more and more expensive. Right? And that's having a tremendous impact in terms of the economics of chips out there. Right? What it forced a consolidation of companies that can actually produce the latest technologies, because they have to have the volume to be able to buy those equipment and operate them. So there's an impact here. We're going to end up in a situation where there's only a handful of companies that can actually produce and manufacture chips at the latest technologies. Right? And we know where that leads us in terms of economic rules if you have a very limited of companies doing this. Okay. The second piece is now I'm actually shrinking the number of transistors so I can put more transistors on a chip. What am I doing with that? Well, what we've seen is people are actually doing integration of more components and more technology on the same chip. Right? They can't go faster, right? As we said earlier, the chips are not necessarily going faster. But they're actually, if you look at the trends over the last 10 years, the CPU speed has been pretty much steady. But they can actually add more. Now, that has also had an impact in terms of the number of manufacturers out there. Because there used to be Intel as a component manufacturer, CPU manufacturers, and then you had all these component manufacturers that would sell pieces around it. Now, all these components are getting aggregated into the core CPUs, right? So there's less and less of those actual second-hand or third-party manufacturers that add value. Okay, so there's significant consolidation there as well, which means now you only have a handful of manufacturers that are making their own CPUs, right? Intel, AMD, Apple, Samsung, Qualcomm. I don't know if you know any other. Broadcom is in a special place. They do telecom stuff and access stuff, but that's it, right? So that's going to have another longer-term impact in terms of what's going to be available. Now, the ecosystem basically of chipset has radically disappeared. Okay, this is kind of the little worry notes, but if you look at CPUs, they're getting pretty amazing. I put a slide up there just to show that this is the iPhone XS, and you see the Geekbench score up there, 11,000 in terms of the score itself. The iMac Core i7 is an 18,000, right? So the capacity, the processing capacity that I have in this device here is at the same level as the fastest desktop that were released 6 months ago, right? That's pretty incredible. Right? If you go into, let's get out of the desktop class and go into the server class, right? The CPUs that are in the server class, right? The 2.3 gigahertz, 18-core Xeon device is only 4 or 5 times faster than what I hold in my pocket. So that's pretty incredible to see that, those are have gone to a point where I can actually hold, a high-end computer in my pocket. Okay, so now in terms of storage trends, this is one area where a lot of people will think that Moore's law applies, and it doesn't. Right? If you look at the top here, the graphics is a bit small, but from 2000 all the way up to 2016, you see the red curve and that's the amount of gigabits per square inch that is actually possible to put on a disk. Right? So we had a pretty high growth early at the beginning of the millennium, but then we have a flattening out at this point where we're not seeing that increase in density. Right? The same thing for cost. At the top there, you see early 2009, 2010, costs were still going down pretty quickly. Then you get to the middle of the curve, and now the cost of storage has actually flattened out. Okay? So that, as we think of, hey, how do we build things, right? Or what are we going to build? We have to know that storage cost is not something that's going down, right? It's not something that's gonna disappear. Okay? It's actually getting somewhat more expensive compared to how we can produce that data. There's a curve out here. Some people might say, yeah, but what about flash storage, right? That's following Moore's law. It is in terms of density, absolutely. But there's years and years and years ahead before the actual overall cost of flash storage is actually going to catch up with the cost of hard disk drive. At that point, we'll probably see that curve start going down again. But we've got a while to go before we're there. Okay. So just see, make sure I've, yeah, so silicon solutions will stay more expensive for a while. Okay, so let's tie all this together, right? We're going to go through how the computing models from 1970s to the future and look at what was in the data center, how we connected that to our actual devices. And that'll kind of let you understand where we're at today and where I think things are going to go. Okay, 1970s, we have the mini computer. Most model is I have this mini computer at the central data center, right? And I have display devices or terminals located across the organization that allow me to interact with that. But the compute, the storage, the display, all of that is done at the mini computer side. 1980s, we see something new appear, right? The personal computer. Okay, so at the time where the personal computer appears, now we have display and we start to have applications that are being run directly on that computer. Okay, the networking has evolved as well, and we now have a shared network where packets are running on a cable connected to multiple computers. Back then it was all about debugging the cables, who stepped on it, and where it was moved. But most of the storage in the compute still stayed in the mini computer. We saw terminal applications start to appear over there. What really changed is somewhere in the 90s, where cost of storage went down, but also we ended up with a switch network, where now we had the bandwidth to be able to move information rapidly within the enterprise. And then the storage, the compute, and pretty much everything worked on the personal computer. This continued to evolve in the 2000s to the point where today's central, large, massive computing facilities are designed with connecting a whole bunch of PCs together with networking, right? So that's really how this evolved. Now, in the 2000s, right, we can look at the same thing, but now we're going to try to project ourselves forward with the phones. Okay. So what do we have? Early 2000s, right? I have a phone. It has a display. Everything that's on the display is actually sent to me by the network. And the applications that exist are all in the cloud. Right, so I've got a phone network that allows me to connect, and I've got SMS, and I have a few SMS applications that I can actually interact with over the cloud. Certain countries had a lot. North America didn't have much, but Europe had a lot of SMS applications. Get to almost 10 years ago, we've got 3G, LTE, and now the smartphone appears. Right? The same kind of evolution that we saw in the PC world. Now I have a device in my pocket where I'm starting to have compute and applications running. Okay? This is where we are today when you look at it. Storage and compute is still in the cloud. Right? I've got an application here which actually we'll call a cloud application that has a front end on my phone, right? A small application. It does some compute here. And then I have the storage and the massive compute that's done in the cloud. So where are we going to go going forward? Well, we talked about the compute being highly powerful here. The problem is, I put storage here. Problem is, I don't know how long it's going to take before we have storage that we can put in our pocket to put a lot of data. Right? So as we go from here to here, this storage is probably going to stay for a number of years up in the cloud. So getting into talking about where we store the information, where we do the compute. Well, we have the processing power on the devices to do a lot of compute. With 5G, in a few years, we'll have the network capacity to be able to transit data very, very quickly from place to place. We could say 5G is a bit analogous to a switched network in the sense that it's actually dividing physical area and providing MIMO, or direct connection between the antenna and the different phones, right? So we're actually doing, I don't know, a switched network, but over space instead of over switches and cables. Okay, so kind of giving us a feel for where we're going and where our applications, or how our applications should be designed. I can't talk about all this without talking a bit about AI. But I'm not going to, we've had a great presentation this morning by Benjo, so I'm not going to say anything except to say that in terms of real applications, right, if you look at the Gartner hype cycle, we're way up here. Everybody's super excited, but we haven't fully grasped what AI means, right, in terms of what are the real things. And yeah, we had the innovation, right? We're at the peak of inflated expectations. Everybody thinks AI is going to make a big difference, but we haven't gone through the throat of disillusionment and the slope of enlightenment before we get to real applications that are making a difference in our lives. So Gartner says 2 to 5 years, somewhere on there, right, is when we're going to do this. Rise of AI, I think one thing that we need to recognize is the fact that in terms of information retrieval, and we'll talk about information in a second, it can really scale very well from small samples to really large samples. So it allows us to do the stuff that we do well with solar and really add to that significantly. And it can also accelerate significantly repetitive processes. We're not talking about generalized AI here. By the way, they have it on the curve somewhere. I think it's down here. Artificial general intelligence. We'll see where that comes in. Okay, I thought I'd give you an example. I don't know if some of you saw. I found this application. I put it in my slide, and then I saw they actually presented it at the last Apple keynote. I think this is a good example of how applications are going to be built in the future. I don't know if you've seen this. So HomeCourt is an application where you actually take your phone and you put it to record a game of basketball, right, or a practice of basketball. And what it will do is it will recognize who's the player that's shooting to the net, right, and has the ball actually gone into the net, and where that player is on the court. And it will record all that information and do all of that processing, that image processing and all of that, all of the AI processing on the device itself. Right? And then it'll store the video and all of those data points directly into the cloud so you can access it further later. But immediately on the spot, the device will tell you, hey, this player shot from here and he got a 3-point shot in. Right? So that's a good example, I think, of how applications are going to be progressing forward, where a lot of the pre-processing, a lot of that intelligent artificial intelligence is going to be done on the device because we have the computing power. And then we're going to push the information to the cloud to be accessed later and be reviewed later. Right. That's a really, really cool application. So that's for technology. Now let's look at human information and start at the very high level. Rise of literacy. So over the last, 50 years, there's been a significant increase in terms of literate population. Right? Basically, everybody can read and write nowadays on the planet. And that's pretty significant. That also correlates to rise in reduced birth rate and increased economic capabilities and all this stuff. But that's really important in terms of information. If you look at the labor force, right, in the UK, you see that the labor force has gone from 25% having a bachelor's degree to now almost 40%. So people who are out there are actually information workers, people who are out in the workforce, right? So in 2012, that's 6 years ago, there's an estimate that there was 230 million knowledge workers in the world. I tend to say that has continued to increase significantly over the last few years. Right? So the majority of people today are actually information workers. They're generating information. They're creators of information. Now, we want to build applications that are going to target this market. If we were to automate all of that, it would be a $6 to $7 billion industry. That's their estimate. I don't think we want to automate all of their work, right? But what we do want to automate is where they waste their time, and they spend 38% of the time searching for information. Now, that's huge, right? That means 40% of their time, if I can figure out a way to present to them information more rapidly, I get the opportunity to improve their lives significantly and improve their productivity significantly. Okay, so people create content. There's an impact on the written conversation. What are people writing? Evolution of humans, we used to write on pads to write transient information. Then it went to the memo. And there's a whole bunch of things that we do today that have been built in this world, the world of the memo. Right? Classifying organizations, filing cabinets, organizing information in a specific way. That has lasted most of the last century. Then, and those memos were sent around, right? They were copied and passed on to different people so that everybody had seen it. Or they would have these brown envelopes with people writing their names to say, hey, yeah, I've seen it, right? That's evolved into the email. Right? And the interesting piece with email is now you started to have a conversation. You were able to reply to that memo in a more direct fashion. Right? And the emails started increasing in speed, and we've now moved to the instant message, where a lot of the conversations today are actually done in an instantaneous way, SMS or instant messaging platform. That has had a significant impact in terms of the human race, right? And how we communicate. We've evolved. Woo! Even better. Woohoo! No, but we've developed new ways to communicate in a written way. And I think that's the big thing here, right? Our written language has now become conversational. The conversations that we had, right, verbally, are now written. It's very often where we see this, right? A couple together at a restaurant talking to somebody else on their phone, right? Chatting with somebody else on their phone. That's huge. We're seeing a transformational power of technology here where people have actually changed the way they communicate, changed the way they interact with each other to go into a world where now a lot of the conversations are actually written. Interesting stats, for the first time in 100 years, or more, I forget, the phone was 1898 or something like that, the invention, the number of calls dropped in the UK by 1.7%, right? So you can already see people are preferring not to talk, but to write, right? Yeah. So what's the impact of the written conversation on our businesses? Well, there's a bunch of stuff, right? People are starting to use Slack, Microsoft Teams, Google Hangouts. We saw it in our own organization when we started using Teams. People are now commenting directly on documents and chatting, and it's much faster to chat than to actually pick up the phone and have a 15-minute conversation. So it's increasing productivity, but it's changing the way we do business significantly, right? Now we're sending messages in a store and forward way. We're capturing some of that value of the business, right? It's changing the way we capture information. I'd like to ask the question, what if we could archive all that content? What would be the impact on organizations, right? I think there's a weird transition happening as well because Google search for voice is up 35%, or 35 times in the last 10 years. My wife doesn't actually call people, but she doesn't type text messages either. She dictates them to the phone, and then she has them read back when they come in. So we're still using the voice interface a lot. So I'm not saying the voice is going away, but what I'm saying is a lot of it is now captured and written down. So, now we're in a world where the information that the organization has and the conversation that are happening within organizations are actually written down. So there's a great guy from Gartner who wrote a book, Infonomics. And what he said is, at a very high level, the information that organizations have are actually assets for them, right? If you can capture all of the know-how of an organization in a written form, right, and start mining that, it's tremendous. So, collecting the know-how of the enterprise, real fast growth in terms of the enterprise data that are being collected, right? So that has an impact because we talked about storage earlier. If I'm growing the data really, really quickly, and that's, 10% is double every 7 years, 24% is double every 3 years, anything above is double the amount of data that an organization had within a few years, right? So what we want to do here is reduce the cost of that information retrieval. We want to reduce, it takes a lot of energy to organize information, right? Human energy and effort, or compute energy and effort to organize that information. So if we look at the different stages of a cost model for evaluating information, well, the pre-search, everything that human does up front, we have work that we can do here to improve, right? As Will was saying earlier, if there's a way to present the information at the right time, then we're saving a lot of that whole query negotiation at the upfront. How we present it and where we present it also makes a difference at the back end. Okay, good and the bad. I'll do this quickly because I'm running out of time, says the lady back there. Private data collection. Okay, that's maybe a good, maybe a bad. Facebook has 179 billion users. They have shadow profiles for all the other ones. Right? They have photo decomposition since 2016, right? They can see where you were, who was on there, where are the objects on those pictures. They collect financial profiles from third-party vendors. Right? Everything that you buy, which store you bought it from, all of that is tied into your profile. Your internet browsing history, when you start a relationship, what you have in common with that person that you started a relationship with, right? And that gives them 29,000 categories for ad targeting. Okay, so there's people who have concerns, and there's law, right? There's GDPR rules that are coming. There's the California rules that are there. The California rules that are coming next year. And then the users as well, right? There's applications that allow you to do end-to-end encryption. Apple has done corporate positioning in terms of saying in front of Congress, yes, we want regulation, and we're never going to share anybody else's information. Where at the other end of the spectrum, you have a Facebook and Google, which I can't change my slides fast enough. When I wrote the slides 2 weeks ago, it was the Chrome 69 scandal where they said, oh, you have to log in to be able to use Chrome. Last week, or the week before that, there was a breach of 40 million users through APIs at Facebook, and Google Plus shut down because they had another breach, right? So all of that happened in the last 2 weeks, and it continues to happen every day. So can we make confidentiality built in our application? Can we create a world where personal information is not monetized, or at least we're giving the choice to the user as to when it's monetized and when it's not? Question mark, don't have an answer. Second thing, which I think is important, is peak complexity. Joseph Tainter said something very interesting in his book. He said, societies collapse when there's so many specialization, right? We always, when we solve problems as a society, we add a new system. We add a new set of people, right? So when we over-complexify the societies, people become over-specialized, and they don't care anymore about how the system works. They just say, hey, give me a simple picture. I don't care anymore. And nobody really understands how this whole system works, so very quickly society collapsed behind that. So that's his theory. I think we have peak complexity in some of our application. I walk into a bank, and then they show us, the guy's going to the website, and he's clicking buttons and nice UI, and then suddenly, pop, there's a terminal window that appears, and he's still using terminals to actually send commands to a back-end server that dates back from the 60s or the 70s, right? So yeah, I think there's peak complexity, and we got to start thinking differently, right? People have a bit of information overload, right? And it's getting to the point where they don't know where the information is, but we don't want our organizations to fail. Right? We don't want them to go into a bubble and not understand the purpose of the business. Right? We want them to be engaged. We want them to have the information they need. And the only way to do that is to actually disrupt complexity, really get rid of complex systems. Uber is a good example of disruption of complexity in the taxi business. You know Uber. I'm not going to go over this necessarily. So Technology for the good. Just like Mark Twain said for decisions, right? In an abstract sense, they're neither the good or bad. So is technology, right? However, there's decisions or the technology we build can have truly bad or good consequences. And that's really our choice to decide where we're going to go. So what's next? Well, we want to build something really cool, and we've learned a bunch of stuff here. We have the opportunity to reach all humans, right? We want to have the mobile devices do the processing and store the data in the cloud, at least for the next little while until that changes. We want to enable seamless conversations, right? We don't want to force users to adapt. We want to allow people to store their conversations, especially in the business setting, because now we're creating value for the organization. We probably want to rebuild some complex systems from the ground up, right? Rethink those systems with the technology and the means that we have today. And we want to use AI to reduce that information overload that really makes it difficult. So, what are you going to build? That's it. Any questions?